In this episode, we take a beginner-friendly but exam-ready look at Ansible, which shows up in Linux Plus because it represents the modern expectation that administrators can describe and apply configuration consistently instead of rebuilding systems by hand every time. The trick with this topic is that it can sound like pure tooling, and that can make new learners either tune out or overfocus on memorizing names. A better approach is to understand the mental model Ansible uses to decide what to change, where to change it, and how to verify that the change happened in a predictable way. That mental model is built from a few core ideas, including an inventory of targets, playbooks that describe desired outcomes, modules that perform specific actions, and collected facts that help automation adapt to real system differences. If those pieces feel coherent to you, you will be able to answer exam questions even when they are phrased in unfamiliar ways. The goal is to make the terminology feel like a set of connected concepts rather than a collection of separate facts. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A practical way to frame Ansible is to start from the problem it is trying to solve, which is that Linux environments tend to grow from one system into many systems, and many systems create two predictable pain points: inconsistency and time pressure. Inconsistency shows up when two servers that should be identical end up with different packages, different service settings, or different permission boundaries, often because they were changed by different people at different times. Time pressure shows up during outages or security response, when the worst moment to rely on memory and manual repetition is exactly when you are forced to do so. Ansible addresses both problems by letting you express the intended state of systems in a repeatable form and then apply that intent across many targets. That repeatability is not only operationally convenient, it is a security guardrail because it reduces configuration drift, makes baselines easier to maintain, and makes changes easier to audit. When the exam talks about Ansible, it is usually testing whether you understand that it is a configuration automation approach built around describing actions and desired outcomes in a structured, repeatable way. Another important foundation is understanding what Ansible is not, because misconceptions lead to wrong answers and unsafe expectations. Ansible is not a replacement for understanding Linux fundamentals, because automation can only apply the decisions you encode, and bad decisions applied consistently can still be bad. Ansible is not primarily a monitoring system, even though it can gather information, because its main purpose is applying changes and enforcing configuration intent. Ansible is also not an always-running agent that sits on every managed host in the way some other configuration systems do, which matters because that design influences both security posture and troubleshooting patterns. Beginners sometimes assume automation implies a heavy footprint everywhere, but Ansible's typical model is to connect to systems when needed, perform tasks, and then disconnect. That model affects how you think about access control, because you need a secure way to reach managed nodes, and you need to ensure the automation itself has only the permissions it truly requires. When you can describe Ansible as on-demand configuration execution rather than permanent host-resident control, you will better understand why the exam uses the word agentless. The inventory concept is one of the first exam-level building blocks, because automation needs a defined answer to the question of which systems are being managed. An inventory is essentially a list of managed nodes and the metadata needed to reach them, often including host names, groupings, and connection variables. Grouping matters because administrators rarely want to treat every server as unique, and inventories allow you to define sets like web servers, database servers, or development hosts, and then apply different behaviors to each set. That grouping is a safety feature as much as it is a convenience feature, because it reduces the chance that you accidentally apply a change to the wrong class of systems. A beginner misunderstanding is thinking inventory is just a static list that never changes, but in dynamic environments, inventories can be generated or updated automatically, which helps automation reflect reality. Even at Linux plus depth, the key is recognizing that inventories define scope, and scope is how you control blast radius. If you know how Ansible decides which targets are in play, You can reason more confidently about how changes are applied and how mistakes are prevented. Playbooks are the next core idea, and they represent the high-level description of what you want done across your inventory. A playbook is structured so that it can specify which hosts or groups it targets, and then list the tasks that should be applied to those targets. Beginners sometimes think playbooks are just scripts, but they are better understood as declarative-ish task descriptions that aim for predictable outcomes rather than raw, fragile command sequences. The value is that playbooks are readable, shareable, and reviewable, which makes them suitable for collaboration and for change control. They also support consistency because the same playbook can be run repeatedly, and good tasks are designed so rerunning them does not keep making changes once the desired state is reached. This is a major reason automation reduces drift, because the playbook expresses what correct looks like and can be reapplied to restore alignment. On the exam, playbooks are often described as the unit of automation that contains plays and tasks, and the important understanding is that playbooks tie intent to scope through the inventory. Modules are the mechanism Ansible uses to actually do work on managed systems, and thinking in modules helps you understand why Ansible is more than a remote shell. A module is essentially a purpose-built unit that performs a specific kind of change or check, such as managing packages, editing configuration settings in a controlled way, or ensuring a service is started. The module idea matters because modules are designed to be idempotent in many cases, meaning they can check current state and apply changes only when needed, rather than blindly repeating actions. That reduces unintended side effects and makes automation safer than a sequence of raw commands that may behave differently depending on current state. Another important point is that modules often return structured results, which can be used to decide what to do next, improving reliability and troubleshooting. Beginners sometimes underestimate how much safety comes from using modules rather than generic remote execution, because modules encode best practices and expected behavior patterns. For Linux Plus questions, recognizing that Ansible's tasks typically call modules, and modules are the units that implement the work, is often the key to picking the correct answer. The idea of ad hoc usage comes up because Ansible can be used for quick, targeted actions without writing a full playbook, and the exam may reference this as a way to do one-off administration across multiple hosts. Ad hoc execution is useful when you need to perform a simple action quickly, such as checking a service state or applying a small change to a known set of machines. The important beginner distinction is that ad hoc actions can be convenient, but they can also increase the chance of undocumented changes if they are overused as a substitute for tracked playbooks. In other words, ad hoc usage can solve immediate problems, but it can also create drift if it becomes the primary habit. A mature approach is to use ad hoc for investigation, verification, and limited controlled adjustments, and then fold persistent changes back into a playbook so the desired state remains documented and repeatable. The exam often expects you to know that Ansible supports both styles, with playbooks for repeatable automation and ad hoc for quick execution. If you can explain the trade-off between speed and maintainability, you will better understand why certain scenarios call for one or the other. Facts are another exam-visible concept, and they relate to how automation adapts to differences among systems while still remaining consistent. Facts are pieces of information Ansible gathers about a managed node, such as operating system type, network interfaces, memory, and other details that influence how tasks should be applied. This matters because not every system is identical, and sometimes the correct configuration depends on the environment, such as selecting the right package name for a distribution or choosing the correct configuration file location. Facts allow playbooks to be written in a way that is conditional and adaptive while still being centralized and repeatable. Beginners sometimes interpret facts gathering as invasive or complex, but conceptually, it is simply automated discovery of properties you would otherwise check manually. The security value is that facts can reduce mistakes, because automation can confirm it is working with the expected system type before applying changes. At Linux Plus Depth, the key is understanding that facts support decision-making inside automation, enabling playbooks to be more portable and less brittle. Agentless is one of the most testable descriptors in this topic because it distinguishes Ansible's common management approach from systems that require a persistent client process installed on managed nodes. In an agentless model, The controller initiates connections to managed nodes when it needs to run tasks, performs the tasks, and then disconnects, rather than relying on a long-running agent on each host that constantly checks in. The operational advantage is reduced host footprint and often simpler host maintenance, because there is less software installed and fewer always-on components to patch and monitor on every node. The security advantage is that you reduce attack surface in one dimension, but you must still secure the management channel and the credentials used for access, because the controller's ability to reach many systems is powerful. A beginner misunderstanding is thinking agentless means no dependencies at all, when the reality is that remote execution still relies on standard management access methods and appropriate permissions. For exam purposes, you should be able to say that Ansible is commonly described as agentless because it does not require an always-running agent on each managed host, and that description connects directly to how it is deployed and secured. Access control and privilege management connect tightly to Ansible concepts even when the exam does not explicitly label them as security topics. Because Ansible performs administrative actions, it needs a way to authenticate to managed nodes and then execute tasks with the required privileges. The core principle is least privilege, meaning the automation should have only the access it needs for the tasks it performs, and elevated privilege should be used deliberately rather than by default. In secure environments, teams often separate who can edit automation definitions from who can run them, and they also separate the controller's access paths from general user access paths, because automation credentials are high-value targets. Beginners sometimes treat automation as safe simply because it is automated, but automation can magnify mistakes and can magnify misuse if an attacker obtains control of it. This is why review, controlled access, and auditing are part of the Ansible story, even at a beginner level. When you understand that Ansible is powerful centralized access, you naturally think about guardrails, which is exactly the kind of reasoning Linux Plus likes to test. Troubleshooting Ansible at a conceptual level becomes much easier when you map failures to the same building blocks you have learned, rather than treating every failure as an opaque error. If a run fails against a host, one category of issue is inventory and targeting, meaning you might be hitting the wrong host, missing a host, or using incorrect connection details. Another category is connectivity and authentication, meaning the controller cannot reach the node or cannot prove identity in the way required. A third category is privilege and permissions, meaning the controller can connect but cannot perform the action because the account lacks the required rights, which is often a deliberate boundary rather than a bug. A fourth category is task logic and state, meaning the tasks do not match the system's current conditions, such as expecting a package that is named differently or expecting a configuration file that is elsewhere. Facts can help reduce that last category, but facts also introduce their own dependency, because if facts are missing or unexpected, conditional logic can fail in surprising ways. This mental framing is valuable for the exam because scenario questions often describe symptoms indirectly, and recognizing which category fits the symptoms guides you to the right answer. It is also helpful to connect Ansible back to the broader infrastructure as code, IAC, mindset, because the exam often treats these topics as part of one evolving approach to administration. Ansible can be used to express and apply configuration intent across many systems, which supports baselines and reduces drift, and that aligns naturally with the idea of keeping infrastructure definitions in version control. When your playbooks represent the intended state, you can review changes before they are applied, test changes in safer environments, and roll back changes if a change breaks a service. That reduces risk and improves reliability, which are core administration goals, not optional extras. Beginners sometimes assume automation is about speed alone, but the deeper value is repeatability and clarity, which also supports security because repeatable configuration reduces hidden surprises. When the exam describes a need for consistent configuration across multiple servers or a need to reduce manual repetition, it is often pointing toward Ansible-style automation thinking. Understanding that link helps you answer questions about why automation exists, not just what it is called. Another common misunderstanding worth addressing is the idea that automation removes the need for careful change planning, when in reality automation increases the importance of planning because changes can propagate faster. A small mistake in a playbook can affect dozens or hundreds of systems, which is a bigger blast radius than a manual mistake on one system. The counterbalance is that automation also makes it easier to implement safe patterns, like peer review of playbooks, staged rollouts to limited groups, and consistent verification after changes. In other words, automation can be safer than manual change, but only when it is treated as a disciplined process rather than as a quick hack. This is also why modules and idempotent task design matter, because they reduce unintended side effects and make reruns predictable. For Linux Plus learners, the exam-friendly takeaway is that Ansible is used to apply configuration consistently and repeatably, but safe use depends on controlled scope, clear intent, and careful handling of access and privileges. When you can explain both the benefits and the risks, you demonstrate mature understanding rather than memorization. By the end of this episode, you should be able to describe Ansible as an automation approach that applies configuration and operational intent across multiple systems using a controller, an inventory of targets, and playbooks composed of module-driven tasks. Inventories define scope and grouping so you can control where changes go, while playbooks describe repeatable intent that can be reviewed and reapplied to reduce drift. Modules are the work units that perform specific actions in a more predictable, idempotent way than generic remote command execution, and ad hoc execution exists for quick, targeted tasks while still fitting within the same model. Facts provide system information that allows playbooks to adapt safely to real differences between hosts, improving portability and reducing brittle assumptions. Agentless describes Ansible's common model of on-demand remote execution rather than requiring a persistent agent on each managed node, which influences both deployment and security posture. When you carry this cohesive mental model into exam questions, you will recognize the right answers because they align with scope, repeatability, and controlled privilege rather than with tool trivia.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.